I have you back. Let's go ahead and click back on this. Let's go to the slideshow, current slide. All right, we've already seen all this, so let's just move on through. Okay, base jumping. You've got some questions on base jumping in your homework. All right, jumping from fixed objects, building, antenna, span, like a bridge or an arch or a cliff. Okay, like El Capitan out in the California National Forest, National Park there. Can't remember what it's called. Man, terrible. Or jumping off the Eiffel Tower. There's all kinds of base jumping things. Without a parachute, a person would reach velocity of about around 200 miles per hour. Depends on their orientation. Calculate this kinetic energy. All right, let's do this together. All right, 200 miles per hour. Upon landing, this energy would be dissipated into the person's body. Not good. That's why people use parachutes. Okay, because our last problem that we're going to do, but we're going to figure out what is the energy that the force that a parachute generates on you. Okay, all right. So here we go, and we'll look at these different base jumping. I don't think I'm going to go into those different because I've already got some base jumping things for you to watch that I think are good. All right, but let's go to that problem. Okay, first of all, I forgot what the problem was. I already forgot the problem. Oh, let's just make up the mass then. All right, sorry about that. So let's say base jump. If you no parachute. Reach 200 miles per hour. Okay, what's your kinetic energy? All right, what is your kinetic energy? Did any of you see? Is on Fox. I might have to look it up. It's called like Heaven Sent or something like that, where this gentleman he jumped. Hold on one second. I'm gonna. Where this guy jumped from and landed in this big huge net, and I mean that he didn't have any way to steer himself, for the really to keep him from splattering all over the desert floor, but somehow he pulled it off. So anyway, this would be what would have happened. This is how much energy he would have hit the ground with, and we're going to find out that the force that how much he caved into to a stop. Look at this. So what's this? Let's say the mass of the person is 65 kilograms. All right, so we've got to calculate the. We got to calculate the kinetic energy. Well, we've got everything we need, except we've got to take that 200 miles in an hour, in 1 hour, and multiply that by 1,609 kilometers or meters per mile times 1 hour is 3,600 seconds. So there's our good old 0.447 that we always multiply things by. So 200 times 0.447. Now when I put parentheses around things, that means I'm multiplying. In case you've forgotten that little trick, it's been a long time. That's what we're doing. So you take 200 times 0.447, 89.4 miles per meters per second. Now, let's figure out that kinetic energy. That would be 1/2 of 65 times 89.4 squared. Okay, now my calculator will do that all in one step. 0.5 times 65 times 89.4 squared. That seems high to me. So I'm going to try to say, oh yeah, no, that's probably about right. So I'm going to make sure it's right. 0.5 times 65, and I'm going to put that 89.4 squared here because yeah, there it is. So that's 250, almost 260,000 joules of energy. Okay? 260,000 joules of energy. Wow. Wow, wow, wow. All right. And then to bring that to a stop, you need a force times distance. Well, what if you smash into the thing? So this guy was free falling for 200, except he had a lot more mass than 65 kilograms. He's kind of a big guy. He's probably like, me. He's probably around 110 or so, 105 kilograms. And bam. So this would be a lot higher. And the force that he hits times, that's why he fell into this huge net that's about 3 stories high that collapsed real slowly while he's in it. And it just kind of caught him like a big bungee cord type thing. It's like a reverse bungee type thing. Force times distance equals the kinetic energy to bring that thing to a stop. So if he only makes a dent of about 3 centimeters, 0.03 meters, then the force that you're going to hit is going to be 260,000 joules divided by 0.03. Whoa. Divided by 0.03. Ouch. That's almost 9 million newtons. That's pretty close to 9 million newtons of force. Ow. That would hurt. Okay, let's go on to the next segment.